In the summer of 1941, German tank crews on the Eastern Front faced something they had never seen before. It was not faster, it was not more powerful, but it refused to die. Shells bounced off its sloped armor. Its tracks moved through mud where German tanks sank, and worst of all, it was everywhere. The machine was called the T-34, and from that moment on, Germany made a decision that would quietly fail for the rest of the war. They would try to copy it. When Germany invaded the Soviet Union, they expected outdated tanks and weak resistance. Instead, German Panzer crews reported encountering a tank immune to their standard weapons. The Panzer III and early Panzer IV struggled to penetrate the T-34's armor at normal combat ranges. Its wide tracks allowed it to move through snow and mud that immobilized German vehicles. And its diesel engine burned less easily than German gasoline tanks. German commanders were stunned. This was not supposed to exist. Captured T-34s were sent to Germany for analysis. Engineers measured every plate of armor, every suspension arm, every weld. The verdict was clear. The Soviet tank was simple, but brutally effective. German engineers admired the T-34's sloped armor, wide tracks, low profile, and rugged suspension. They recommended copying these features directly, but Germany faced a problem. Their industry was not built for simplicity. It was built for precision. German tanks were assembled with tight tolerances, complex transmissions, and high-grade alloys. The T-34, by contrast, was designed to be built by semi-skilled workers in evacuated factories east of the Urals. German engineers tried to combine Soviet design with German engineering standards. The result was a machine that looked like the T-34, but behaved like a German tank. The Panther tank was Germany's answer. It borrowed the T-34's sloped armor and long gun. On paper, it was superior. But in reality, it became a mechanical nightmare. The Panther was rushed into service at Kursk in 1943. Its engines overheated. Its transmissions failed. Its fuel systems caught fire. More Panthers broke down than were destroyed by enemy fire. The Germans had copied the shape of the T-34, but not the philosophy behind it. The T-34 was designed for mass production. It could be welded poorly and still fight. It could be driven by barely trained crews. It could be repaired with a hammer and spare steel. Germany could not match this. Each Panther took far longer to build than a T-34. Each Tiger tank used enough steel to build several Soviet tanks. And each breakdown meant specialized parts and trained mechanics. By 1944, the Soviets produced tens of thousands of T-34s. Germany produced only hundreds of heavy tanks. The battlefield became an equation Germany could not solve. Germany failed to copy the T-34 for three reasons. First, industrial philosophy. The Soviet Union built weapons to be crude and replaceable. Germany built weapons to be perfect and irreplaceable. Second, logistics. German tanks needed precision fuel, trained crews, and long maintenance cycles. The T-34 needed only fuel and orders. Third, time. By the time Germany produced tanks inspired by the T-34, the war of numbers had already been lost. They copied the design, but they could not copy the system that created it. The T-34 did not win the war alone, but it forced Germany into a war of production it could never win. German engineers understood the machine, but they misunderstood the idea behind it. They believed copying a tank was enough. The Soviet Union proved that copying a tank without copying the factory, the workers, and the strategy meant nothing. Germany learned too late that you cannot win an industrial war with perfect machines. You win it with machines you can replace.